Hello and welcome to another episode of the Oxford MAT Livestream. My name's James and it's great to have you with us today, going live at 5 for some more MAT questions and things like that. Joined today in chat by Prisma, but on the livestream virtually by just me. Hi to people in chat, hi to Kai, hi to Rebel, hi to some anonymous people. How would you react if someone was trying to sabotage another applicant's application? That does not sound like a very nice thing to do. I almost don't want to ask what you mean. Hi to Raphael and Imogen. Anonymous says, yo guys. Hi to everyone else as well. I don't know how you'd sabotage an application. I guess you would maybe, I don't know, pretend to be them and do something terrible. Good. Adrian says, how am I? I am good, thank you, which reminds me to do some sort of poll to find out how you are. Hi Esme and Chris. Hi Everest Gawa. If you're new here, then good to have you with us. The way this works is we do some questions on screen, and there are people watching who are joining live chat. We don't use YouTube chat, we use Slido chat, so that people can be anonymous or choose their own usernames without setting up a Google account. Don't tell Google. We're currently doing a poll for how is your day, which is something we do at the start. As always, the average is about 4, which is pretty good. I think I'm having a 4-star day. And as always, I'm looking out for people who vote 1 or 2 stars. I don't know who you are. I don't know where you are. I don't know what's happened today that's 1 or 2 stars for you. Unless you're Liz Truss. Am I allowed to do that joke? Liz Truss, if you're watching, then it's great that you've joined us after an up and down day for some mathematics. For people watching this in the distant future, Liz Truss was a Prime Minister, briefly. You might need to look them up. Cool, okay. Good day today, says someone, because I finally got my glasses. Welcome to the glasses team. We could do a vote. Let's not do a vote. Glasses team. We will, when we find you, you'll be our glasses team. We're great. Somebody's just started polar coordinates in further maths, so that's pretty nice. Good bit of topic. I remember doing polar coordinates briefly on the Oxford Online Maths Club earlier this year, and it being very, very confusing for everyone. A psychology test I didn't know about, says someone else. And people are doing Tamura. Oh, I guess Tamura's already happened, maybe. Has Tamura already happened? I know that UCAS applications have happened, so it's great having loads of UCAS applications in, but people doing Tamura, did that already happen? I think that was already gone. We'll find out, I guess. Let's switch back to chat. Chat has voted 3.9 on average. That's how chat's feeling. We're going to try and get that up, of course. Nobody's voted 1 star, so that's pretty good. Cool, right. If you'd like to tell me not to do any political jokes in the future, then you can tell me not to do any political jokes. Tamura has happened, smiley face. Yeah, people all right? You survived? We're still here? It's all right. Okay, right. Survivors from Tamura, look, here they are. They did a big maths test, and they seem pretty fine. Oh no, one of them's just described it. This will come through in a second. One of them's just, as I said that, somebody put a post in to say that Tamura was torture. Here it comes. So they survived the torture or whatever to do that, TMUA. And if they can survive Tamura, then we can survive math as well. Good, okay. So the plan for today is that we try and do some questions from MAT 2020. What was going on in 2020? Several good things happened in 2020. We started doing this live stream. We wrote, I think, quite a good math paper with some good questions on it. We also wrote some bad things happened in 2020. We wrote a question with a typo in. We made a mistake. I know it's rare, but it does happen that humans make mistakes. We made quite a bad mistake and then fixed it during marking. But that's not going to happen this year. Good, okay. Any questions in chat first before we jump into doing questions? Matt questions. I did Matt 2016. You've given yourself 96 out of 100. Easy. First Timur paper. Kate's not a fan of the first one. Sort of want it a lot harder than previous years. Scared for Matt. Matt and Timur are written by completely different people. So there's shouldn't be any correlation between whether Timur is hard or not. Yeah, this was the one where we got the definition of an odd function wrong. Question 4 had a typo in it. This is in the notes section, by the way. If you're interested in the history of past papers, we put some little bits together in the notes column in past paper. Right, shout out to Prisma, who's doing a great job as chat rolls through here. And hello to Ornum Senach, which is, I think, my name backwards. Yeah, so mistake. Let's do the mistake first. So humility is important, right? Humility. This is what we should have said. This version's been corrected and edited. This is what we should have said. A function is said to be even if this is true, and a function is said to be odd if this is true, which is a definition some people have seen before, not everyone's seen. We put it in just to make sure that everyone was on the same page. Unfortunately, what we actually printed in the version that went out to everyone had an extra minus sign in just here, inside the brackets, an extra minus sign there, which it makes it nonsense. It means that the function is 0 for all x, I think, which is quite bad. So that's pretty bad. We defined exactly one function to be odd. We marked it really kindly. We gave people marks both ways around. Yeah, so we told everyone that an odd function has this to be true, which is true. If that's true, then f of x is equal to minus f of x for all x. You can just switch how you look at the x's. They could be negative or they could be positive. And if that's true, then f of x is 0 for all x. Right, probably not what we meant, but sadly was what we wrote. So we gave people marks if they interpret it like that, and we also gave people marks if they interpreted it with what we meant to say. There were a few people who wrote down, I think you meant to say something else, and I've done the question with the proper definition of odd functions. And there's some people with maybe, I don't know, maybe confidence is a factor of that. Good, okay. What's a good score to aim for MAT this year? I always say 70. 70 is something I say is a good MAT score to aim for. Can I do the computer question? Let's do the computer question. I love talking to chat, so I'm going to talk to chat a little bit. Do I have some sort of AMD Threadripper Pro? I have quite a normal workstation. The story of 2022 is that I built at home, working from home, I built at home a much better computer that's really great. But I did not invest properly in having a good broadband connection. So if you watched Maths Club earlier this year, the computer was great, the graphics worked, except the internet connection was rubbish, and we dropped a load of live streams because my internet was bad. So I now do them from work back on the same machine I was using in 2020. So sadly, not currently on a supercomputer. Please petition don't actually petition my boss to do a supercomputer. That'd be good, wouldn't it, for streaming? Just for streaming, just a streaming machine. No, my actual computer is about the size of a pint of, about the size of a milk carton. Right, good, okay. People are asking if the test this year is going to be easy or not, which is not something I can answer. But they're also asking if we write solutions in the answer booklet, which the answer booklet is the question booklet. It's got a fixed number of pages, it's got a couple of extra pages at the back, it's got blank pages throughout. There's space in there for you to write your answers. Please write in the booklet, because the booklet gets scanned. If you write on loose bits of paper, they're probably going to make their way to us, but we know that the booklet is going to make it all the way to us. Gawal wants to know if Gauss is here. Gauss missed last week. They turned up just to say they couldn't be here last week. Gauss is one of our live stream regulars. I never know if it's one person or if it's like a collaborative effort like Bourbaki. Question 67, people think, one person thinks it's hard. Low 60s, could you still possibly get an interview, especially if the rest of your application is quite good? This is possible. If you would like to see a histogram about this. So what we're doing MAT scores, this is my final answer for what's a good MAT score, by the way. On the MAT page, so if you get into the MAT page, scrolling down on the MAT page, in the table of past papers, there is feedback. If you click on the feedback, you can get a histogram. Everyone loves a histogram, right? A histogram of different outcomes by MAT scores. This is on the MAT page. If you find the MAT page, you find the MAT page from this website you're on, probably. Good, right, okay. Have I started reading personal statements? I have read a couple of personal statements. I am not going to read all of the thousands of personal statements. We got a team, but I have already seen a few personal statements just to check everything's working before we do stuff. We haven't decided. We don't do any shortlisting before we get MAT scores in. So get everyone to do MAT before we do anything else. Right, cool. Let's stop focusing on my mistake and let's choose a question to do. I'm going to turn on a poll. Yeah, so Chris, I can technically look at them. Our system hasn't actually gone live yet to tutors, and they're not going to make any shortlisting decisions until MAT's happened. Let's do what next, which I know is a bit weird before we've done anything first, but that's a list of all of the MAT questions on this paper. If you've got a copy of the paper, which you've grabbed from the MAT Livestream website or something, and you've got feelings, you can vote on which questions we should talk about. The computer scientists are here and we'd like to talk about question 7. Question 1A is getting votes as well. I got some flack about question 1A, which is one of mine. Got some flack about it on the internet afterwards. People started arguing with me about what a square is, which is not a position I thought I'd be in. 3 and 5 are doing well there. Okay, we've got a few votes coming in. You are allowed to vote for everything, although voting for everything counts as joining in, but doesn't affect what happens next. Good. Someone says, I've got an interview. Hang on, let's just do this. I think this is a congratulations is in order. I've got an interview from a university without them seeing my MAT score. 2 question marks, says someone in chat behind here. Congratulations, well done. Some universities don't need to see your MAT score to invite you to interview. Some universities just want to interview you. They must have liked your application or really want to have you on the course. Go for it. Sounds good. Oxford, I gotta wait for the MAT scores. Yeah, we saying congrats? Yeah, so MAT is used by Oxford, Warwick will take it into consideration, Imperial will take it into consideration, and then Durham and Bath also have some data sharing agreements with us. It's a bit complicated. When do we know if we've been shortlisted? You find out at the end of November. Yeah, either way. Good, right, that's a lot of votes for question 1A. Can we start with a short question? Let's start with a short question, and there's a lot of votes for elliptic curves, because elliptic curves, very difficult. But I did not see 1A coming. Should we do 1A? Yeah, 1A's at 29, they're kind of tied. They are tied. Wow. I'm going to wait for more people to break that tie. I use prime numbers to vote in the poll. So 2, 3, and 5, and 7. Okay, yeah, fair enough. Is that the ones that people... No, that's not the questions that anybody does. Nobody does 3 and 7. Okay. If you vote for all the prime numbers, then that's not a combination. It's not an exam run. Okay. I think I'm going to go over to 1A, which has now won the vote. Plop. Chat's back. Offer for Cardiff. Congratulations. Lovely place. Does interview outweigh the MAT? So, really good MAT and then really bad interview might outweigh it in that sense. We look at everything together. We don't really do a balancing game, I suppose, with some scales or something. We look at both. We've currently met you and we've done some maths with you at interview when we get there, and we've still got your MAT score on record. Okay. What's the difference? Yeah, okay, universities. Oxford's great, we do really great teaching. You can find out more on the Oxford website. Let's do 1A. So, 1A, A square has centre 3, 4. So I got some flack on the internet for referring to the centre of a square. What is the centre of a square? I think it's unambiguously what I mean as being this point in the middle. It's equidistant from all 4 sides and equidistant from all 4 corners. It has centre 3, 4 and it has one corner at 1, 5. So these are coordinates for where the corners are. Let's try and draw this. Maybe I should draw this in the big empty space on the screen. 1, 5 is one of the corners. That's up here somewhere. And 3, 4 is the centre, which is over here somewhere. Can I remember how to do this question? Is it just vectors? So 1A is often just something. If you've done this question, you would like to describe it as just something, then that's fine with me. But yeah, okay. So the problem is that this square is not lined up with the axes. It can't be, because for a square, the way you get from the centre to a corner is you go the same distance along as you go up. This bit and this bit are the same length. That's just how squares are broken down into quarters, I guess. It's the same distance along and up. That top corner of the square is also a square. And that's not what's happening here, because to get from the centre to go up, we go -2 left and 1 up. And those are not the same distances, sort of 2 along and 1 up. So this is not a square that's lined up with the axes. Gauss is here. Hi Gauss. Gauwa was asking if you were here, Gauss. Gauwa, look, Gauss is here. Is it better to get fully complete questions, or just the first couple of parts of every question? A fully complete question is worth about 15. The first couple of parts would be worth maybe as many as 6 marks. So it depends how wide you go. If you do the first couple of marks for each of 4 long questions, you could get maybe 24 marks. If you do your full question, it's 15. So in that sense, it was a choice between doing one full question and lots of wide bits. Of course, you don't know that you've got 6 marks on all of these questions. You might have 3 or 4, in which case the algebra is a little bit different. It depends how wide, how deep, how big's a rectangle. Good. Do we check social media and anything embarrassing that you've done? No. Good, right. Are you saying we should? I'm not sure we should. It's fine to do embarrassing things on social media. I mean, look at me doing a live stream on YouTube. It's definitely more embarrassing than anything you've done. Good, okay, we're going to find the other corners of this square. Starting to worry slightly. I'm not worried. Worrying is for no, other people. Pretty sure I remember the question. So there's kind of the corner that's opposite. That one's easy to think about, I suppose, because if it's opposite, then I can go 1 down and 2 across to find out where this other corner is. This is my centre. I'm trying to go down the other side, so I need to go an equal displacement as a vector over this side. I'm kind of not really using vectors here, am I? I'm using kind of distances along each axis, I guess I'm imagining a square that's like this. Amazing, perfect drawing of a square. No issues at all there. Where would this be? So this would be down 1, so comma 3, and across 2, so 5. Okay, that was not one of the options, but that is one of the corners of the square, I think. So I guess multiple choice questions are sort of do them in a normal way, try and do maths, but you should keep checking against the answers to see have you got down to one of the answers yet. Because if you have, you can stop. That sounded really stupid, I'm sorry. You're cleverer than that. I'm trying to work out where the other 2 corners of this square are. So I suppose what I want is something like, I want to rotate this around. So I want to pick up, maybe it's, if you imagine it being cut out of card or something, I want to pick that up and rotate it 90 degrees, because that's how you get from one corner to the next corner of a square. You rotate by 90 degrees. I can kind of imagine doing that. I'm going to draw something that's definitely quite bad because I want to match up with my light blue picture of a square. I can kind of imagine rotating around like that, 90 degrees, right? Now, rotating by 90 degrees for vectors is actually very complicated, but here I can kind of imagine doing it, cutting out this kind of solid object for this triangle and rotating it around. I like imagining solid objects. Randall's done this with roots of unity, which sounds, I mean, someone stopped the timer on complex numbers, but sounds very, very advanced. Any method is fine. If you get, on the multiple choice questions, anything goes. If you get to the right answer, you get to the right answer. I'm trying to add small numbers together while also doing a live stream, which, you know, it's Oxford. Cool, so 4, 6 is another corner, which is not one of the options. So I'm going to have to try and find this corner of the square down here. So that's going to be down and across like this. I'm going to take this triangle that I just had and imagine shifting it over to find that bit opposite. It's a very strange way of constructing a square, I suppose. And that's going to be at 1 to the left is 2, and 2 down compared to 3, 4. 2 down is 2, 2. So finally, I've got to one of the options, and I'm going to stop because I've got to one of the other corners of the square. Complex numbers. Trax wants to use complex numbers as well. Oh, Erdish is here as well. Hello, Erdish. Do we look at math scores contextually? Yeah, we get some contextual information from the rest of your application. If you told us in the rest of your application that had 5 different further maths teachers, wait until it comes back. 2, 3, 4. 1, 2, 3, 4. Are we back? Are we back? Stream has frozen. Try reloading. Ooh, let me know when the stream is back. Will they let me know when the stream is back? And it's back. Okay, good, right. Hi again. I just said that the internet was bad at home, but the internet here is really good. And then that happens. Good, right, we're back. Cool, was frozen, we're back. I was just explaining to someone why it's not 5-5. And I can see how they got to 5-5. They went similar distance along, 2 along, and 1 up again to get up to 5-5. But sadly, this shape is a rectangle. and not a square. It's a rectangle because it's longer along this side. It's 4 along this side, and it's only 2 along that side. Good, right, cool. Song. Sort of hoping that the song wouldn't be broadcast, but here we are. Do I think so? There's somebody in chat saying that somebody solved the Riemann hypothesis, which I was not aware of. I will need to look this up because that would be very exciting. Ooh, good strategy. I'm unmained in chat. Says if you're thinking about this shape, then you should maybe find the other corners just to be sure, and they will be 1, 3 and 5, 3. So then this would also be an answer, and the questions only have one correct answer. So there's something suspicious going on with this thing that turns out to be a rectangle. That's a good strategy. So you can use the facts if you like. You can spot that something's going on if you know that. You can use the information that there's only one answer. Okay. Yeah, Perrin was here too, look. Switch to every new problems and transfer. Should I be revising problems I can't solve? I always ask people to practice by doing things that they can't do straight away. Practice being stuck. Practice getting unstuck. Okay, that's 1A. You end up with this kind of windmill picture, I suppose, and finding out where all the 4 corners are. Just for fun, I want to try and do it using complex numbers because someone in chat suggested that, and this is off topic. This is not. Don't worry. If you tune in during this, then I'm really sorry. What's the complex number solution? Is it something like 3 plus 4i for a complex number for where the center is, plus, so the corner is at -1 plus 2i, and then rotate that by 90 degrees by multiplying by I? It is that, isn't it? Take the same center, but rotate the displacement by multiplying by I, and then you get, no, multiply by I? The displacement -2 plus 1i, James. -2 plus 1i. And then multiply by I to get -2i -1. What a great method that I can't pull off. There we go. 2 plus 2i. That's 2. Ha! And because you're multiplying by I, that naturally makes you rotate this way, so you get round from 1/5 to that one naturally straight away. Huh, maybe that was good with complex numbers. Cool, right. If you've just joined us, ignore all of the complex numbers. They're not on MAT, but you're allowed to use them if you want to. Rotating by I cubed would turn it the other direction. Yeah, sure. So rotating by I cubed would give us -2 plus 2i. Oh my gosh, 4 i's together with minus is 1. So then you'd end up at 6i, 4 plus 6i, which is that top right corner. If you don't know what's going on, that's fine. I'm not certain I know what's going on. Right, good. Okay, complex numbers. Stop the timer on complex numbers. Should we do it? Let's go to question 3 and then have another vote. 24 minutes in. It's quite slow for a multiple choice question, but we also did a lot of voting and a lot of chat. The rule of thumb is about 5 minutes for a short question, I think, but they'll vary. Some of them are harder than others. Yeah. Can you use complex numbers on the long questions? Yeah, you can use complex numbers. So long as, so down here, for example, where it says by completing the square or otherwise, your otherwise could be anything, but probably by completing the square is a good idea. You don't get bonus marks for using complex numbers. You don't get, style points for using something really out of the box and weird. Mathematicians actually, in my experience, mathematicians prefer straightforward methods over fancy methods anyway. But it's not really, that's not really something we assess, right? So this or otherwise is opening us up to a whole sort of, do you want to use complex numbers? Do you want to go for it? Good. Why does multiplying by I rotate it? Kai, at some point, you're going to learn about complex numbers. They're amazing. They're fantastic. Multiplication represents rotation and scaling at the same time. It's brilliant. Multiplying by real numbers scales things. Multiplying by purely imaginary numbers multiplying by I rotates by 90 degrees. Multiplying by other things rotates by other amounts. They're really good. They are, in some sense, the right way to represent rotations. Okay, this question is lovely. I really like this question. I think it's extremely hard, but who knows? We'll get there. No style points. I once used the phrase style points and it wasn't entirely clear I was joking, and then everybody thought that they could get some style points. So I have to be really clear that you don't have to impress me. You don't have to do style. Right, cool. Me advising people not to try to be stylish, just in case. By otherwise is by guessing. I don't think you can prove a given. Hang on a minute. No, I think your otherwise has to be an actual mathematical technique that finds it rather than guesses it. If you're guessing, you don't know that you found it. What questions have I written? At some point, I'm going to have to make a quick YouTube video that's like, these ones are mine. Blame me for these ones. Blame other people for the other ones. That sounds like a third channel sort of content. We're not doing starter points. S1. M1, A1, S1. Good, right, should we do question 3? You ready? I'm going to start the timer. So some people really like elliptic curves, and you don't need to. You don't need to have heard the phrase elliptic curves. Something I like about this question is that secretly it's an elliptic curve. That's a cool thing. You don't need to know anything about it, but maybe later in life on a maths degree you'll meet elliptic curves and you'll recognise the picture. I just quite like that about a math question. If it's not, it's a sort of in-joke, I suppose, in that we put it on because it's an elliptic curve and some people will see it and think, haha, elliptic curve. It's the sort of in-joke, but it's a harmless in-joke because knowing that it's an elliptic curve gives you no advantage. It is not useful information. The things that we're going to do to it are not really anything to do with elliptic curves in mathematics. It just happens to be one. It's like if we had a donut or something and everyone's like, oh, it's like a torus, or like a thing. It's just a donut in a question. Good. Okay, AM in chat has been researching elliptic curve cryptography recently, and it is cool, I agree. Recommended to anyone interested in computer science. Yeah, it's really cool. It's also very hard. Implicitly differentiated. I think you get full marks, Adrian. We will get there when we get there. Yeah, no, I remember marking this actually. Yeah, implicit differentiation. Not everybody knows what that is, Adrian. Erdish, if you solved the twin prime conjecture, Erdish, that'd be very surprising. Good, yeah, prime numbers, everything's going on. Right, cool. We've got sidetracked. We need to actually do this math question, which the setup's on the screen at the moment. There is an equation that's going to come all the way through, so I'm going to write it out really big over here. Wait, no, over here. Just to be clear, when people sketch a curve like this, they're sketching all of the points that solve that equation. So this is not like sketching, it's not like sketching a function where you would only have one value for each value of x. Here we're sketching all of the points x, y that satisfy some equation. That's what it means to be this curve with equation blah. There's a bit of a subtle difference there about whether you, for example, whether you just want the positive square root or whether you want all of the solutions, including ones with negative values. This is the sort where we just want any solutions to work for this. And it's not going to turn out to be the graph of a function, because it's sort of, if it was going to be a function, it'd be sort of double valued around here, it'd be no values in between. And as the question says, the curve only exists between alpha and beta, and then for x bigger than gamma. There are sort of two chunks of graph. And there are 3 points with x coordinates alpha, beta, and gamma, which were just mentioned as being the kind of limit extreme points of where this graph exists. But otherwise, so we're talking about it. Oh, so these points A0 and B0 are where it crosses the x-axis. Okay, so nice stuff. Oh no, sorry, I wasn't calling out anybody for calling it a function. I didn't even see that you said function. So just trying to address the curve sketching elephant in the room. Kind of two different sorts of curve sketching we do. One is just here's a function of x, and the other is please sketch all the solutions. You might have seen other math questions that are sort of like please sketch all the solutions to cos x equals cos y, which means all the points x, y, such that this is worth having a go at. Even if you have seen the math question before, even if you haven't seen a math question that does that, it's just worth having a go at because it's a bit of a mind-bending thing to think about. There are places where cosine x is equal to cosine y. Okay, let's actually do the math question, I promise. We got an equation. Mostly we're going to come back to this equation. The picture's very pretty, but we are going to come back to the equation. So the values for A and B, the only thing we know about A and B are that these are where y equals 0. So I should plug y equals 0 into this equation. And I get some sort of cubic equation which I should then solve. And I think I was told earlier on that yes, A is negative and B is positive. Neither of them are 0, which I can see as the root of my cubic down the bottom here. So I solve what I get is x equals 0 or x is plus or minus 1. So I'm good, right? A is minus 1, B is plus 1. Okay, good. I think A and B don't come up again in the question, so hey, I guess we got a mark for working out A and B, and then off we go. Okay, so part 2, I'm going to complete the square. I'm not going to do it otherwise. I'm interested in, so the way I think about this is, for which values of x is there a or several, are there solutions for y? This is how I might think about these regions where the graph exists. That's the thing I've been told about alpha, beta, and gamma. Those are the kind of extreme points. The graph exists between alpha and beta, and it exists for x bigger than gamma. So again, I'm trying to pair up the things in the question with the points where they appeared in the information I was given. So delta only appears as this y coordinate of these points. Well, what are alpha, beta, and gamma, right? I have no chance of explaining this unless I can work out what alpha, beta, and gamma are. Ah, they turned up in the question the first time. I literally look back up, I find the first time they appeared, aha, that was the definition of where the curve existed. X between alpha and beta, x between gamma. So there's a lot of, you read the question, and then you look up, and you think, oh, I can't remember what that is either, so I need to look up higher. And that kind of way of building backwards to find out, where's this, what are these things? That's how you work out, I suppose, what am I going to do? How are these things defined? Where do they come from? Okay, so we've got alpha, beta, and gamma. And then this question to me, for when are there solutions for y? Solutions for y is a little bit odd. I'm used to solving for x, here solving for y. But if I look at this in terms of y, it's a quadratic. And we know loads of stuff about quadratics, right? We know when they have solutions or not. And the question tells us to complete the square, or says by completing the square or otherwise. So I'm going to complete the square on this quadratic on the left. That is my plan. So I'm going to write it like this. Okay, so what do I know? I can see that there will be solutions for y if and only if this bit, which what do I mean? I mean this bit, the other stuff. Let's move it all onto the same side so I can point at it. And so I get a nice expression. This bit has got to be positive. Got to be positive for solutions, which is a cubic. Okay, interesting. This is actually the cubic for part 4. And sometimes maths is like this, that you hit the solutions but not hitting the information in the same order that you thought of the questions or things that you had going on. Ooh, polar edish has come back from the grave and put a link to what they claim is a revision site. We're not responsible for the content of external links, especially if they turn out to be rickrolls. But it's got 2 thumbs ups, which either means it's a very funny rickroll or it's a revision website. I might check that out in a second as well. Yeah, it's like finding the turning point of a quadratic, says Kai. It's like finding this point where the coordinates of where that turning point is, but the coordinates you're thinking about it in terms of x and y the other way up. It's a little bit odd. I'm going to have a look at this revision site as well. It's now got three thumbs ups. Second page HTML. Oh my goodness, it's got an official countdown to the MAT. It's not a rickroll as far as I can tell. It's got some content about topics. It's got some YouTube links. Oh, nice. It's got a maths test, which doesn't look MAT level. It's got some other stuff. Useful, inspirational stuff. What's this content? Oh, some of these links don't work. Oh no, all of these links don't work. Erdish, your links under math topics are broken links for me. Right, cool, we're debugging somebody else's website live on stream. Oh, it's in dev. It's got 6 thumbs ups. The only bit, what am I missing? The only bit I can get to work on your website is the bit that's links to other people's YouTube channels. If I click enough buttons, do I get back to this one? No, maybe not. Right, in dev. Okay. Always keen to see what people have built. What am I doing though? I'm trying to find the value of delta. Completing the square or otherwise. So what's delta then? So delta is the actual y value where it changes. Where it changes from having maybe 2 solutions. So if I imagine changing x, maybe I've got a little scanning line. What's x? I've got this is what's in my head. I've got this kind of scanning line. Maybe I'm decreasing x. I'm getting two solutions out for y. And then as I decrease x, there's a bit here where I get no solutions for y, and then a bit where I get one solution again, briefly, just on that point, and then two solutions for y, and then scanning, I get one solution for y, and I get no solution for y. Okay, so in terms of quadratics, that means whether or not there are solutions for y, it's something to do with whether we're at alpha, beta, gamma, because those are the points where there's exactly one solution for y. Okay, one solution for y, that would only happen if the right-hand side was 0. And also that makes sense to me is, if we're over here, that's when the right-hand side thing is positive, and I get these two solutions. I could carry on solving for y. This is how you derive the quadratic equation, if you've seen that before. You rearrange it, complete square and rearrange. I can keep solving for y over here. If I do that, then the next thing would be a square root, and that depends if this thing on the right is positive or negative, with the kind of critical in-between bit being, when's the thing on the right-hand side 0? So I'm going to keep doing this point. Obviously, in the test, I would move on now. I write down right-hand side equals 0 and I keep doing it, but I'm going to keep explaining it because I want to show this scanning line again. I think this is the key to understanding this part of the question, is to understand, as you change x, something really complicated happens on the right-hand side. I'm hardly selling what happens as you change x. This number changes. Sometimes it's negative, sometimes it's positive, sometimes it's 0, because it's a cubic, right? Sometimes cubics are positive, sometimes they're negative. And that has consequences for y, because as I change x, maybe I get some solutions involving the square root here, and maybe I don't. 1, 2, and 1 again, because the cubic on the right, I guess that's gone negative again. I guess cubics can do that. The cubic could be, let's try to sketch this cubic on the right. The cubic's going to be, there's a bit of a weird graph because it's got, don't think about what this graph actually shows. I'm trying to sketch it's not really y on the y-axis, but I'm just trying to sketch this cubic, right? So it's x cubed minus x plus a quarter, so it's like this, I guess. Right, so I suppose maybe it's negative for a little bit around here, and it's positive over there. Okay, good, right. Taking a moment to stop and understand this, though, is nice. It's the only thing you can do if you're stuck, right? If you're stuck, the only thing you can do is to try and draw little pictures and try to understand what's going on. You don't have to draw them on top of the question. I'm doing that so I can keep the question on the screen. If you do a test, you get blank paper next to it where you can draw little pictures and try out different ideas. That's the only thing you can do when you're stuck. And actually understanding this, having this sort of idea about whether this thing on the right-hand side is positive or negative or 0, gives us enough information to do all of the other parts of the question, down to 2. We can do 2, 3, and 4 now. We get loads of marks. I think it was Emily who talked about just doing the first bits of questions. Emily, if you can get down to this idea, just all we've done is complete the square and then thought a bit about whether this is positive or negative, we're going to get so many marks out of this. And then we can maybe move on if you're doing this. Search where you go wide first. Okay, yeah, for the actual test, Fermat's here too. The extra for the actual test you write on, there are blank papers. On screen here, I have only put the questions in. There are blank pages inside. If you would like to see the actual test paper that we sent to the printers, that's on the MAT webpage. So if you go to the MAT Live, go back to MAT, go to the MAT page from there. The actual past papers that you're downloading are the ones that are printed with blank pages throughout for you to write on. Cool, don't worry about it. There's blank paper in the booklet for you to write on. Usually enough paper. Good. What are we doing? Oh yeah, delta, we decided, was the value of y when that cubic on the right-hand side is equal to 0. Well, then on the left-hand side, I would have y minus a half squared, and that would be 0. So y would have to be 1/2. And that's fallen out really simply because we did a lot of thinking about what it would mean. Okay, explain why it's symmetrical about the line y equals delta. Well, I suppose I can carry on solving and write down if cubic is positive, then y is, I guess we can just carry on solving, plus or minus square root of the cubic. So it's symmetric because of the plus minus sign. There's a bit added, a bit subtracted. I think Eric just asked how much justification do we need to do in part 3 and 4. Enough so that we know you're not bluffing. If you write down something like, this is symmetric because all curves are symmetric, or if you write, this is symmetric because maths is inherently symmetric about its nature, or if you write, this is symmetric because positive and negative numbers balance out, then none of those really sound like you've actually done the thing. Some people put a lot of detail into their working out here and started talking about y equals like delta plus u and y equals delta minus u, which I think is not really necessary. But yeah, okay. Y equals delta just means y equals 1/2 by the time we're here. But hey. Okay. So if you just say, well, I looked at the picture and it kind of looks a bit symmetric, then no matter how you phrase that, that's not very convincing. We're just trying to sort out, for the justifications, we're just trying to sort out, one way to think about it is if we're just trying to sort out people who actually know what's going on versus people who have no idea but will write something anyway. If you're a diligent student who's watching a MAT live stream on a Thursday afternoon, you seem keen, then probably one of the honest people who would never lie or try to bluff. So you don't need to worry about it at all. If you're watching this live stream and you're a sort of bluffing sort of person, then whoa, watch out. What does symmetric mean? I guess it's talking about this reflection symmetry. The way that this thing is, the sort of symmetry in lines that you have is reflection symmetry. I guess you can have other sorts of symmetry in lines like glide symmetry. Let's not go there. This curve has reflectional symmetry in the line y equals 1/2. Above the curve you get something, and below the curve you get something similar. Has this reflectional symmetry. And that's because the curve itself is actually just this, 1/2 plus or minus some stuff, square root of some stuff. And for different values of x, it doesn't really matter what this is. If it exists, then there's a bit of curve where you added it and a bit of curve where you subtracted it. So you get the symmetry, that wherever there's a bit above, there's a bit below. How did you make the left x side equal to 0? Oh, in part 2, I identified that was exactly the point I was interested in, where there would be a unique solution for y. The only way to get a unique solution for y out of this equation, 1/2 plus or minus square root of some stuff, is for the stuff to be 0. Otherwise we'll get two solutions, which is generically what happens. We get these kind of two solutions, one here and one down here. But if stuff is 0, then you get just one solution, which is what's going on at these extreme values, alpha, beta, and gamma. Ugh, look at this. X cubed minus x plus 0.25 is that thing, which is that thing, which is that thing. That also looks like a proof that you can flip it in the line by doing some reflection, writing down an inherent symmetry of the equation. Good. By inspection. This is proved by James. Don't believe us, go and ask James. And then James has to mark it and decide whether or not it's like one of those circular logic things. Okay, symmetry. We've already found a cubic equation that's got roots alpha, beta, and gamma because we worked out what alpha, beta, and gamma were. They're the points where y equals 1/2. I suppose this is going to look a little bit symmetric, a little bit circular, but it's not circular. It's just a restatement of the same thing. These things go both ways. Okay, so here's a cubic. The roots of this are alpha, beta, and gamma. Part 5 is a little bit weird. On the fence about whether this is a good idea or not. They tell us to do it by considering the factorisation. So if you know Vita's laws, you are not allowed to say, it's just Vita's laws, isn't it? We are told that we must consider the factorisation. I can't remember how we marked this. What have we got? We've got this must be equal to x cubed minus x plus 1/4, because that's a cubic which has roots alpha, beta, and gamma, and so is this. So they must be equal because they have the same roots and they have the same coefficient of x cubed. I just said a lot of stuff out loud that I'm not going to write down, but go with me. This cubic must factorise like this. So then we can multiply out both sides. Here is the Cliff Notes version. Oh, Cliff Notes copyright. Other notes are available. Multiply out, and then the coefficient of x turns out to be, on the left, minus alpha, minus beta, minus gamma, and on the right, it's minus 1. So multiply out and compare coefficients. This is a general trick that some people learn in further maths, I think. So I don't love it, but I think alpha plus beta plus gamma turns out to be the number 1. Is it? Do I mean that, or do I mean the opposite? I mean plus signs, don't I? This is the thing where I got it wrong before, and I'm going to get it wrong again. Minus, minus. Take it back, I want the minus signs. Part 5 is 3 marks. Well, okay, I'll get a mark for writing down the cubics and convincing myself that they're equal. Maybe a mark for multiplying out, a mark for comparing coefficients, which I could do wrong. really concerned that I have done it wrong. Being too lazy. Oh, it's the coefficient of x squared. That would help, wouldn't it? Is it actually 0? Maybe I should do the question. Maybe I should do that question. Yeah, cool. Maybe I should multiply it out. Just so lazy though. Just so lazy to multiply it. Just too lazy. Oh yeah, okay. I get it now. I get it now. I was thinking about this one, which is not what we want. Okay, and the coefficient of x squared. Okay, good. Okay, I don't think anyone saw, so we're good. It's the x squared coefficient that we should look at, which on the left hand side is minus alpha minus beta minus gamma, and on the right hand side is 0. So the sum is 0. Thanks everyone in chat for helping me out there. Nobody saw it, right? Yeah, nobody saw. Okay, good. And this is 0. That's kind of nice. We haven't actually solved for alpha, beta, and gamma because I can't solve that cubic because I don't know the cubic formula. But hey, the sum of the roots is 0. Does that look true? Yeah, it looks kind of true. This one's very negative. These two are a bit positive. This one's kind of equal to the negative. Never mind. We're good. Right. Okay. Last part's a bit algebraically heavy. We're going to have a go at it. It is a rider, I think, but it looks like a complicated rider that's worth a couple of marks. I also think, haha, it's a sneaky. So a rider is some terminology that I used on a previous live stream. I introduced people. A rider is a little extra bit. So I think this is a rider, sort of. It's like a sort of unrelated extra bit. But I also think this is secretly a sort of rider as well at the top. Because this, this extra bit that's got nothing to do with the rest of the question. You can sometimes spot them where we've added in an extra bit of question to be worth a small number of marks. I actually think the last bit might be worth lots of marks. Stream bugged out. Anybody else? I'm going to see if anybody else is having trouble. And then start doing loads of algebra for part 6. Haven't decided where to do the algebra, where to draw the picture. For this I really do recommend drawing a picture. Am I going to draw on top of the picture I've already got? Yeah, sure. C intersects S at 2 other points. Find their common coordinate. Okay, so there's some sort of circle here. Gosh, can I draw this? Not really. This is a terrible picture of a circle. That's maybe the worst thing I've ever done. Oh dear. Oh, that's pretty bad. I hope the stream's bugged out. The stream's good for, oh no, the stream's good for people. People may have seen the circle. It's worse because I've remembered that this software has a circle tool, which I should be using more. Okay, this has got diameter like that. That's not a circle, is it? How do I make this a circle? Myro, behave. Still bad somehow, despite technology. If you've just joined us, the stream's always like this. It's a bit of a mess. No, it's not always like this. This is a unique sort of mess. Right, cool. Drawing a picture is always great, isn't it? Because then you get a sense of what's real. Good. Okay. Our challenge is going to be to find this pink circle and to work out. Find the pink circle and work out where it crosses this curve. Oh, it looks like it only just crosses, right? My goodness. Drag a corner and hold shift to make a perfect circle. Too late now, but I like the one I've got. Good, okay. Chat teaches James how to use the internet. I think we should write down an equation for the circle, because I don't think we're going to get anywhere without it. Oh no, we even get marks for writing down the equation of a circle. By the way, who was it? Was it Emily who was going to come into this question and just do the first couple of parts? Hey, you would definitely get this mark at the top. You could maybe come down here and do. You could maybe come down here and get this mark because you know how circles work. What's the radius? Radius is a little bit complicated to write down. Is it this squared? Yeah, I think it's that. Yeah, seems good. Seems good. Do people want to see how I wrote down the equation of the circle? I wrote it down by thinking really hard and going quite quiet. Oh, Eric, right, no, I just missed a a total whoosh of a really funny joke in chat, but because it was about technology going wrong, it was not funny. Right, cool. Equation of a circle. Nobody wants to see where this came from, right? The nice thing about this equation of a circle is that it involves y minus delta squared. This is the only redeeming feature about this circle. These terms, both horrible. This thing over here is the same as this thing, which we already had an equation for. Y minus delta squared we know in terms of x. So that's pretty cool. We're going to replace that with a cubic. Because we know that, I suppose we've got this bottom fact down here with a star is true for points on the circle, and this fact up here with a smiley face is true for points on the curve. So points that are on both would have to satisfy both, and then we can start solving the simultaneous equations by eliminating y. So we go through again there. How did I get the centre coordinates? I thought really hard about where the midpoint was. I thought I had the ends of the diameter of these points. The midpoint is the centre is in the middle of the diameter, so I added up their x coordinates and divided by 2. And the y coordinates, I guess I added those up and divided by 2 as well. But delta plus delta divided by 2 is delta. So there's the coordinates. And then the radius, I had to think really hard about what this length is. And this is beta. This is beta plus alpha over 2. So do some subtraction to get beta minus alpha over 2 for that distance. But mostly it was thinking in my head and then writing it down. Good. Math is more about gimmicky questions that have a trick to them. Hey. But are quite fun. Oh, good. Okay, right. Step is really a bit more hard algebra and a bit of a slog. Okay. I'll take hard but gimmicky. No, fun but gimmicky. Cool. Yeah. Should I put delta in already? Yeah. Maybe I should always be writing 1/2. I wrote down delta because I was looking at the picture, but yeah, no, it's 1/2. We know delta's a half at this stage, so yeah, cool. I wrote it down because it's printed in here. Maybe I should have gone through it and changed all of these to 1/2 because we know they're 1/2 now. Cool. Okay, so y minus 1/2 squared is just that cubic. So now we get, if I plug in the cubic for points that are on both the circle and the curve, then I will get, oh my goodness, some horrible cubic equation. But I think I just want to point at this cubic and say, aha, it's a cubic. You ready? So this is points on C and S. So very special points that are on both the curve and the circle. You can eliminate y and get this cubic. Ah, it's a cubic. Cubic's got 3 solutions. I know 2 solutions already. Oops. I know 2 solutions are alpha and beta. I've got a mystery third solution, but I can use that trick that I had. I can think about the coefficient of x squared on both sides. And if I do that, I can find an equation for alpha plus beta plus, what are we calling the other one? Has the other one got a name? The other one does not have a name. I'm going to call it, what's a good letter? Zeta. Well, that's a bit of a weird choice. Alpha plus beta plus zeta. That's the other one. And then rearrange it. And I know alpha plus beta in terms of gamma because I know that alpha plus beta plus gamma is 0. Good, okay. Can't use gamma because we already had it. How useful is getting Olympiad on XMC? Oh, you get to do the Olympiad, right? So very useful if you would like to do the Olympiad because then you get the one. In terms of Oxford admissions, we got our own test. We will get you to do this test. You don't need to do well on the SMC to do our test. Yeah, I could have used Epsilon, but that makes me nervous for complicated analysis reasons. So I'll use alpha plus beta plus theta. Should we go for it? Let's go for it. Let's try and work out this x squared coefficient. So I think the x squared coefficient is just 1 because the only x squared coefficient is equal to, the only x squared coefficient is just coming from this x squared over here. That's the only way I'm going to get an x squared. But on the other hand, it's also minus alpha minus beta minus zeta. Because I'm imagining taking the cubic that has roots alpha, beta and zeta, multiplying it out just like we did before, but with zetas instead of gammas. Go with me. Multiplying it out just like this, don't make me write it out again, but with zeta instead of gamma, aha, the coefficient of x squared will be minus the sum of the roots. So that's in here. So this number 1, why have I circled the 1? That's not how people write mathematics. 1 is equal to minus alpha minus beta minus zeta. So this is fantastic news. We can rearrange this for zeta is 1 minus alpha minus beta, I think. Which then is probably 1 plus gamma or something like that. Yeah. I remember it being 1 minus gamma in my mind, so I might have to have a little panic. Yeah, the third must be some other. The third is the other solution I'm interested in. It's a mystical third solution. Giving things names is fun, especially I quite like the Greek alphabet. So yeah, a step away from a minute. Can someone summarise? Let's see if we can get a summary in chat. There's a request from an anonymous person. They missed a minute, went to get a glass of water or something because it's almost 1 hour in, and now everything's got zetas in it. You picked a terrifying moment to leave and come back. Sorry about that. I want to see if chat can explain what just happened. Also, is there a mistake in it? One volunteer has said, I would give a summary, but I still don't fully get it. Okay, right. So the superpowered thing that I'm doing is to reuse a trick adapted for this new weird cubic. The trick is that when you're given a cubic, you could imagine writing down its roots, and there's a relationship between the coefficients and the roots. A bit like how when you're solving a quadratic, the constant term of the quadratic is the product of the roots. Something similar is true for cubics. Good. People are saying -1 in chat. Is it -1 for cubics? What have I done wrong? -1. Where's my -1 supposed to be? Oh, I need to move them 1 onto the other side. Ugh. What's it like doing maths with a complete idiot? Right, there we go. -1 in there. Cool. The last line should have a minus sign in it. Oh, right, okay, good. Which is then equal to gamma -1. Because earlier we discovered that alpha plus beta plus gamma was just 0. So we can do a switch. Oh, it's because the 1 went on the right-hand side. Goodness me. I sometimes wish that I made more clever mistakes. You know, if you make a clever mistake, a really interesting mistake, then you've maybe discovered something that you didn't know about yourself, or you didn't know about mathematics, that you discover something interesting where you assumed that the two things were the same, but actually they're subtly different, and you learn an important distinction. But I make a lot of stupid mistakes. I don't learn anything from my stupid mistakes. So it's very disappointing. Struggling out here. Should we do it again? Let's do it again. What have we got? We've got an equation for a circle. Hopefully we're happy with that. We've got an equation for the curve. Hopefully we're happy with that one up there. I want to solve for points that are on both. That's solving simultaneous equations. I don't love all this x and y stuff. I want to eliminate y. So I've taken the y minus a half square bit, which brilliantly matches in both my equations. And I've just substituted to get rid of that bit. Replace it with x cubed minus x plus a quarter. So now I've got down to a cubic. Some of the roots of this cubic we already know, because they're points that are on the curve and the circle. That includes the alpha and beta points. It has to, because those are on, remember those are the ends of the diameter of the circle, and they're on the curve. So those are examples of points that are on the curve. So we know 2 solutions already, alpha and beta. And then we're doing this trick about writing out this relationship between the coefficients of this cubic we know the cubic, versus the roots, which we don't know, we'd like to find. We know 2 of the roots, and the third one also matters, and then just a little bit of rearranging to work out what that third one is in terms of the others. Yeah, so negative roots, negative sum of the roots for a cubic is the x squared coefficient. I think that factor is a little bit complicated, and it is something that some people learn in later on in maths, or is it in further maths? You learn something called Vieta's formulas, which means that some people have seen something similar before. So, not sure how I feel about these last couple of parts really. I think this question is hard, but actually quite nice in that solving for these intersection points could have been horrible. Solving for simultaneous equations could have been horrible, but you can do it by doing this elimination, and then solving the cubic. That's quite nice. I like it when something could have been horrible, but you get to do something interesting and difficult because it turns out to be not that bad. Right, here we go. I have to ask, so somebody in chat. We're doing a 6 o'clock quick break. Remember to drink some water, and people have put some questions in, and then we're going to do some more. We've done so far one short question, one long question. I would like to do more. When you're doing these 15 mark questions, how do you develop or change the way you think for parts like 6? Really good question. I think you've got to train yourself to be a little bit flexible. There is in the mind, because sometimes the parts follow on. Sometimes the parts follow on, and you're rewarded for understanding the previous part and seeing that this just follows on. That we're still talking in parts 2, 3, and 4. In parts 2, 3, and 4, we're still talking about rearranging the equation and writing down facts about when this equation has roots or not, and symmetries of the graph and cubic equation, discovering that cubic. Sometimes they lead together, so your brain needs to be able to recognise that, but sometimes it's just different. For me, I think the trigger is something like, are they defining new things? Where they've brought in here for part 6, let's C denote the circle, which has blah 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 blah. But the circle's come out of nowhere, it's new, so I've got to sit up and pay attention. It's unlikely that the things I was just doing have any relevance to the circle. I mean, maybe they do, and it turns out that there's some nice link that lets me solve the equation. But I've got to sit up and pay attention, because whenever you're given information like this, you just turn it into some maths. You're given something new. Remember back up here, when we were solving for this, what's going on with A and B, the way in was to look back up to find out where A and B were. Then we're asked about delta, so look back up to where the deltas are. Somebody's replaced them with a 1/2, but look up to where the deltas were and find out what they are. But then as soon as I get something new in the question, like this for this next part, everything uses 3s instead of 2s. Then it kind of, that's my prompt, I think, to, maybe we're doing something different now. I should almost go back as if it's the start of a new question. Always go back to that mindset of like, oh, right, fresh question, what are we doing? What is going on? Good. Are marks from easier questions as valuable as marks from harder questions? Yep, 15. Yep, a mark is a mark. If we wanted to do something clever with scalings for easy, hard questions, then we could do something clever with like averages and stuff for different questions, but no. It's much easier. Everyone's doing the same questions. For the same course, people do the same questions. So let's not do that. Jack's seen the Great Wave bottle. It's not merchandise, but maybe it should be. We're not sponsored, but maybe we should be. Right, okay. Should we do that again? Let's do that again. Oh, not sure if you saw my question. Unmained, I have now seen your question, but I'm going to turn a poll on for what next. And I'm going to edit the poll to remove the top 2 options. Bing and bong. They're gone. 5 for winning, that's almost predictable. Short question, part 6, unmade. Right, okay, people are voting for what we're doing next. This is a small break in the middle. Oh, it's gone on longer than I thought. And I'm reading out some things in chat. Coefficient of x squared is 1, but the coefficient of x is minus... I think the coefficient of x is... When you do the multiplying out, I think the coefficient of x... This is a mistake I made. I think the coefficient of x involves products, alpha, beta, because to get an x, you would get like alpha, beta, x. And you get alpha... I guess you know more stuff about alpha and beta, so it's maybe possible to do the question like that. But be really careful when you're multiplying this out and getting these coefficients. Look, yeah, down here I've got my x coefficients look like this. This is me responding to just one person in chat, by the way. Yeah, take into account maybe that you can solve it, I suppose. It doesn't look solvable. I really like your question that doesn't look solvable. There's a petition. Yeah, so we're not doing the... Because I did a joke about sponsorship, there's now jokes about sponsorship in the chat. We're not doing Twitch because I don't understand advertising on Twitch. And I don't understand if Twitch will just put adverts in, which I think would be very annoying if you were watching a Matt live stream and then suddenly there was an advert in the middle and you had to watch some, merchandising thing. Question about exam technique. Do I start with multiple choice? What did Daisy say last time? You can. I think I would like to start with question 1A. That'll be my strat. To be honest, I'd probably read through everything and write little notes to myself. At the end, maybe you can quickly guess the multiple choice questions, but sometimes the multiple choice questions are a good way to just get some marks. So if you ignore them, maybe you're ignoring some easy marks. On the other hand, if you start reading by reading the long questions and you get kind of stuck, then maybe they're running at the back of your head, or maybe you can see them with fresh eyes after doing some short questions. So maybe I would sequence it like that. I'd probably go in and do question 1A. It's so tempting to do it in order, right? Just go in and do question 1A. Okay, great. Do question 1B. Oh, fine, brilliant. Question 1C, don't get it. Look at the next one. Leave some gaps, come back. But maybe doing long, short, long. I don't know. People spend about 45 minutes, I think, doing short questions. I asked some first years. Okay. Twitch forces you to run adverts. You see, it's why we're not going for it. I think Prisma's typing an answer to a question in chat. Question 5 is doing really well in chat, and 4 is doing well as well. And I saw somebody put a special request in chat to just do 4 and 5. Head first in, says Rebel. Off we go. YouTube knows I'm getting... Let's turn the poll off, but I want to do a funny story. YouTube knows I'm interested in uni, so a while back I kept getting adverts about clearing. Hey, so did I. YouTube has worked out that I work in a university, or I'm interested in universities, and yeah, I get advertising, loads of adverts for other people's universities. I don't think Oxford's running any official adverts on YouTube or something. Maybe we could be, so that might be, maybe we could be. The 15th of October deadline is quite a hard deadline. Sorry. I hope that's not a serious request. We have to do it like this. It's really tricky. Good. I'm just having a quick look at YouTube settings while I'm going. This is not a professional way to do a live stream. Does Oxford need more publicity? Does Oxford need more professional live streams? Does Oxford need James to pay attention to what's going on? Maybe. Right, question 5. It's written by the Computer Science Department, but it is for everyone. It says at the top there, for all applicants. I've lost the internet on my second device, but that should be alright. We're good, we're in. Okay. I'm currently running 3 screens, 2 internet connections, we're running Wi-Fi, we're running... Oh, it's all happening. Let's do the sweet question without getting too bogged down by what's going on. Okay, Alfie likes question 5, so that's nice. Question 5s are always written by the Computer Science Department, more or less. They write 5, 6, and 7. Maths department does 2, 3, and 4. We work together on question 1. Here we go. So, Miriam and Adam agree to relieve the boredom of the school holidays by eating sweets. This is just for fun. It could just say they agree to eat sweets. But their mother insists that they limit their consumption by obeying the following rules. Miriam eats as many sweets on any day as there have been sunny days during the holiday so far, including the day in question. As many as. Okay. So example down here, we can see there are some sunny days, and Miriam's eating 1 sweet, 2 sweets. And then here it's not sunny, but Miriam eats 2 sweets because there have been 2 sunny days. Okay, and then over here, but now it's 3 sweets because it includes this sunny day as well, and then it goes up to 4. Okay, good. That's Miriam's rule. Work out how much sun you've seen, including today, and that's what we're doing. That's how many sweets we're getting. Adam only eats sweets on rainy days. Okay, if they care the holiday is rainy, so he looks at the day number up here, and Adam is going to pick that number. So he's got a 1, 4, which is this 4 because it's raining, a 5 because of this 5 because it's raining, and an 8 because of this 8 because it's raining. Okay, I've circled too many things. Sorry, I have this tendency to underline stuff and circle things. It's much worse in real life. Real life, everything on my desk is just scribbled on. Terrible. We could sponsor a 3 blue 1 brown video. Yeah, it's thinking there. Whoa, mega brain. To move quite hard. I wonder if Prisma's going to answer the question about being transgender in Oxford. I would quite like to see Prisma's answer if Prisma's happy to answer that question. We'll see. No pressure. Okay. The holiday is 8 days long and begins rainy, sunny, sunny. And the telling us what your temperature might look like this. Okay, so here's the example. In this case, they've both eaten the same amount of sweets, which is 18 sweets. So this table's quite small, and the ones we're going to be talking about have 30 days, so it's going to be maybe too hard to list all the possibilities. And because I suppose there are loads of possibilities with 30 days, like 2 to the power of 30, which is about 1 billion. So let's not list all the possibilities. 15 are sunny and 15 are rainy. Homework question, how many possibilities are there now? What arrangement of sunny and rainy days would lead Miriam to eat the greatest number of sweets in total? What arrangement would lead to the least number? Okay, so Miriam, when does Miriam eat lots of sweets? And when does Miriam eat the least number of sweets? So whenever Miriam sees a sunny day, that's a sweet today, but it's also a sweet for all following days, because Miriam's looking back at how many sunny days there have been. So if the sunny days are early on, Miriam will have lots of sweets. So greatest will be sunny first. So 15 sunny first. And if it's rainy, first, I guess the opposite. If the sunny days come really late, then they won't have much effect on Miriam's sweet consumption, because she will only have seen them for a few days in a row. So least number is going to be 15 rainy first. Right, so work out the numbers. To actually work out the numbers, I've got to think about the table. I've got to think about having 15 sunny days. I suppose on the sunny days, Miriam would eat 1, 2, 3, 15. And then there are 15 rainy days, but the brilliant thing about Miriam's plan is that she keeps eating 15 sweets every single day for those 15 rainy days. What a great plan. That bit is, so adding together these numbers is the sum of some numbers. Whereas Gauss, when you need Gauss, that is triangle numbers. I don't know. Triangle numbers, arithmetic progressions, Gauss when you were 6. Off you go. 15 times 16 divided by 2 is 15 eighths, 120. And then this bit over here is 15 15s, which is 225. So these things add together to give 345. I feel like Carol Vorderman. Good. Okay. I think I know Jonathan Lee. I think he taught me on something. I can't remember where. Maybe university. Maybe a maths thing. I think I've met Jonathan Lee. Cool. Ooh, good, okay. To show that, in the two cases mentioned in part 1, Adam eats the same number of sweets as Miriam. So I need to think about how many sweets Adam would eat in these two cases. So in the first case, Adam sees these sunny days and doesn't get to eat any sweets for the first 15 days, but then sees on the 16th day it's suddenly rainy, and that's when Adam gets the sweets out. Adding those all together, we get some sort of arithmetic progression again. Do the arithmetic progression, this turns out to be, I think, 345. Okay, and in the second case, what does Adam do in the second case? Have I got confused? No, I don't think I've got confused yet. I haven't worked out the number for Miriam's minimum, the minimum Miriam number, which is the rainy first days. So on the rainy first days, Miriam eats nothing, and then really suddenly starts eating. It gets to 1, 2, 3, 4, 5, up to 15. So she just sees those 120 right over there. So the second case, what does Adam do? In this case, where it's the rainy days first, Adam eats some sweets to start off with, but then it's sunny and Adam stops eating because Adam doesn't eat anything on rainy days, which is still 120. Same arithmetic progression quite a lot around here. Okay. Okay, what are we doing? I think, okay, so now we've got 3 different cases where the sweets are the same. We're gonna have a quick break to check on the transgender issue. So someone anonymous has said, if you don't mind answering, prisoner, if you don't mind answering, I'm transgender and I'm worried about what it would be like at Oxford. How have you found being queer and using they them pronouns at Oxford? If you don't want to share, then no worries. Prisoner, I hope you don't mind if I read this out, because Prisoner has written a comment underneath, which doesn't show up on the live stream. Thanks for asking so nicely. Oxford Queerwise is good. Huge community, and you'll find most students identify under LGBT umbrella. Transwise, we've had some issues, and I won't lie to you about that. Some transphobic tutors in the humanities and some controversies with flying trans flags, etc. However, you get Germs Logic. I didn't read this first. Who has taken my name change in stride and never once misgender me. My tutors also have been ace with name change, and my philosophy tutor never pulls me up on using neo-protein pronouns for ancient dead philosophers, etc. It's a huge community among those of us who get it, and you will find your people here, I promise. That can take time, so don't be hard on yourself. I think university is, from my experience, nicer than high school for things like this. Somebody's requested a tea break, so that's, we do all the issues at once. Cool. Somebody else said something unacceptable in chat, which has been deleted. I think you can have one gender each. You can share with other people if you like, but as far as I care, you can have one gender each. I've got mine, you've got yours. If you want to share with loads of other people, then that's fine, but I think one gender each. Okay, good. Right, let's do part 3 and part 4. So part 3 says, suppose in a sequence of sunny and rainy days, we arranged to swap a rainy day with a sunny day that immediately follows it. How does the total number of sweets eaten by Miriam change when we make that swap? And what about the total number of sweets eaten by Adam? So we're going to think about this general case now. We've got some sunny and rainy days. It's a little bit hard to write down the notation for this. I've been writing quite sloppily, just this sequence of numbers that I've been adding up or doing some stuff to. I think maybe it's time to try and draw a table or something, because I want some abstraction here to try and think about the kind of general sequence, general stuff going on. So I'm going to draw a table like the one they had in the question, right? They had this kind of day. And they also had this idea that I want to steal of saying K for one of the days. Swap a rainy day. Swap a rainy day. So this is like before. There's like, I don't know what going on over here. There's a rainy day with a sunny day that immediately follows it. How does the total number of sweets eaten by Miriam change? Right, we haven't done the swap yet because I need an after table as well. And I think this is my only chance to track this sweet combination days, what's going on. The days are still numbered in the same order, but now there's a sunny one followed by a rainy one. So what are we doing? We would like to know how many sweets they eat. And of course we don't really know that because we don't know what's going on over here. But it's actually, I suppose, something. It's going to be unaffected, right? Because Miriam only looks at the history and Adam only looks at the present day. So if nothing else changes, then this is the same. Same as before. It's only these ones that are interesting. Where, Now maybe I do need some more names. Miriam's rule, what was Miriam's rule? Look back up again, right? Look back up, see what Miriam's rule was. Miriam's as many sweets on any day as there have been sunny days during the holidays so far. I don't know what that is actually. I don't know what that is. So maybe I should put some name in here for like N sunny days. So before, Miriam will be, now I've given it a name, this will be N, and then she sees this sunny day over here, N plus 1. Okay, and then afterwards, there are still N sunny days over here. So Miriam will see this one, but then eat N plus 1 over here, and then on that rainy day, Miriam will still eat N plus 1. So it's pretty good. And then these ones are unaffected, because now if it's sunny, it goes up, if it's rainy, it stays the same. But this bit is unaffected, because the history has now got N plus 1 plus whatever else happens. Whatever else happens still happens. So that's unaffected. What's Adam doing? Adam only eats sweets on rainy days. He's doing K here, 0 here. Adam is now eating 0 on this one, and K plus 1, because the day number is bigger over here. Everything else is unaffected, because Adam is quite straightforward. Adam just cares if it's raining and just looks at that day. It doesn't do anything complicated with history or looking back or counting or adding. Adam just looks at the 27th day of the holiday, it's raining. Let's get the sweets out. So both of those totals have gone up by 1. Okay. Crucial idea for this: if their sweet distribution was fair before, if they're eating the same number before, it would still be fair now because it's both gone up by 1. And that means that in fact, it's always going to be fair, whatever's going on. Here's what we could do. We could imagine starting with the arrangement rainy days first, then sunny days. And we could do lots of swaps to swap sunny days leftwards through the holiday. Am I doing that the right way around? I guess I'm not. We should start with, that's the left. We'll start with the rainy days first on the left, and then all the sunny days. And we know what happens in that case, it's fair, and they eat the same number of sweets. And then we could do some swaps until we get to your favourite combination of rainy and sunny, any combination of rainy and sunny, by swapping sunny days left to fill up, to get them into their positions. Every time we do that swap, the number of sweets will go up for each child by 1, but it'll just go up by 1 for each of them and stay fair as we do all those swaps. That's the idea for part 4, that you can combine swaps together, starting from this combination rainy, then sunny, and swapping things backwards. What's my favourite tea? I drink a lot of Yorkshire tea. Not sponsored, maybe we should be. But yeah, there we go. Normal, but like in a builder's tea, right? Was I supposed to pick something very complicated or something? Yes. I never go into all these things. Some people think that this was a little bit too easy. I don't know. Too nice. I think it is nice. This bit is surprisingly hard to explain. I haven't done a great job on the page. I hope that what I've said out loud made more sense than what I wrote. Explaining that these things are unaffected is worth maybe a mark or 2. Explaining that both of them have gone up by 1, so it's fair. In part 4, explaining that you can combine these swaps together. You might need to do more than one swap, but you can get from some starting fair position to swap the days around until you get to any other position by AM. Altogether, should be all right. Have I ever interviewed a question who wasn't challenged? I'm going to hesitate before I say no. I can usually think of something tough to ask. Yeah, Eric, let's answer your question. Here we go. By actually looking at the web solutions. So we've published these kind of web solutions, which are also pretty handy when we're doing some marking. What is this? This is 2020 solutions. Let's see if I look at the solution, I can maybe remember all the marking policy we came up with live while marking. Where are we? 5. Okay. Retry starting with all the rainy days, repeatedly swapping. I think we want to mark for. So it's 4 marks for this last part, which is quite a lot. The marks on this one go 4, 3, 4, 4. Any arrangement that economics ranges starting rainy days, repeatedly swapping. Yeah, I think the web solution, the model solution that we put out, goes into quite a bit of detail about how to do all that swapping. Here it is. Model solution. I don't think anybody wrote it out exactly like this, to be honest. Something vaguely convincing that swapping is sufficient, and also some idea that you started from fairness. You need both of those ideas, really. I suppose the starting from fairness thing is maybe obvious because we just talked about it in part 2, but it's relevant. So, okay, maybe that's fine. I think this question is good because it's maybe people in chat seem to think that it felt too easy on the way through, but if it was just part 4, if it was just set up and then part 4, it'd be really hard. You'd have to think of this swapping idea, whereas it gets you to think about the swapping idea by getting you to investigate a swap first. Okay, question in chat: can we use pencil for diagrams in the map? Please use a pen. If we can read it, we will mark it. If we can read it, we will mark it. It is going to be scanned this year, so yeah. If we can read it, we will mark it. Sometimes when people write with pencil, it's very, very faint. Right, Alfie's off as well. Bye, Alfie. Are the marks per part decided before the test? Yes. The modern process is that the marks per part are decided before it happens. I'm going to do some advice for question 4, and then we're going to do another vote. So we're going to do 6 minutes on question 4, and then another round of voting. I'm aware that 4 is only for maths students, maths and stats, maths and philosophy. That's written at the top, James. Not for computer science people. So I'm going to not go into too much detail on this. After some setup about odd or even functions that could really be a separate question, there's this part here asking about the area of this triangle, and however you found the previous parts, you should be able to jump in here. I always encourage people, if you can't do a bit, skip in. You should be able to jump in here and get some marks. What part do I want to do? A of theta is the area of the triangle. We know loads of things about areas of triangles, right? We know how to write down the area of a triangle. Base and height. Base and height. Oh gosh, how am I going to find the base and height? I suppose I could split it into two or something. So I could split it into two triangles, because this theta angle is kind of labelled on this triangle. What do I mean by this triangle? I mean the theta angle's here, right? And then it hits this line. So that makes me think of this triangle. I guess that's a right angle. Looks like a right angle. It is a right angle. Because these lines are at right angles. This is y of x. This is y as 1 minus x. These gradients multiply to -1. So they're right angles. So yeah, brilliant. Okay, a little right angle there. Also, it looks like a right angle. Don't quote me on that. So maybe we can get a mark down here for writing down the area of these triangles. I'm stalling for time. This is cosine theta. This is 1. No, it's not. Nothing like that. What am I doing? This is something like 1 over root 2 or something, isn't it? Because this is 1 down here. I found the 1. It was hiding over here. Here's a 1. This is 1. This looks like a 45-degree triangle to me. In fact, I think it is. Because this is at 45 degrees. It's halfway between. Line of symmetry between the x-axis and the y-axis. 45 degrees. So we've got lots of 45-degree angles. Right angle over here. Everything's nice. I know this length over here is 1 over root 2 because I'm aware of this 1, 1, root 2 triangle. And I can scale it. So hypotenuse 1, that's 1 over root 2. This thing over here, I guess, is 1 over root 2 tan theta. Opposite over adjacent. It's tan theta. Yeah, okay, good. So this small bit of triangle, the one that I drew, is going to be size 1/4 tan theta. Plus, don't forget about the bottom bit, which has got area 1/4, I think. Because it's 1/4 of a big square, cut diagonally, or because it's 1 over root 2 times 1 over root 2 divided by 2, something like that. Okay. Good. Are we being alright in chat? Are we being nice? Chat's always been nice so far. I hope chat's being nice. Okay. Normally when I tell other people about this, I'd say you should do live streams because chat's really nice. We're all here to do maths. Okay, good. There's some geometric arguments to explain why this thing's true. To say if you've got, you can think of this as if you've got a negative theta, it goes the other way, and you get this kind of negative space. I just said negative space like I'm some sort of designer or something. So this is like negative theta, so here it would just be this bit. Oh my goodness. Miro is being updated, connection restored. Thanks, Mario. Good update. Great timing. This area down here. And then some sort of argument about this being, oh, it's the half triangle minus a bit rather than plus a bit. Those bits are the same, so this is half triangle down here plus a bit, half triangle minus a bit. Those things balance out and you get 1/2. There's this other bit where people pointed at this section over here as being a of minus theta, which also works. It's a bit harder to imagine. Can I explain how I got 1 over root 2 tan theta? I saw this right angle triangle. Slow motion replay, I saw this right angle triangle. I knew one side, and I know an angle, so I pushed over here. I wanted this thing because I wanted the height of this triangle. I had the base, wanted the height. Push over here, I know that the relationship between these is opposite over adjacent, it's tan, so I wrote down something that would give me the right tan theta. Really because I saw the theta label, I saw this label, and I desperately wanted this height so I could be done. So I wrote it down using trig. There you go. Good, okay. Okay, cool. We're being nice. Good. Okay. Other advice for a minute here. Sketching the graph is quite fun. It's worth imagining how the graph changes as theta changes. Let's talk about how when theta is negative 45, it's 0, and how it increases and it goes up. Maybe be like this. So that when theta is plus 45 degrees, you get all of this 1/2 area. Lovely. All of this big right angle triangle. And in between, it goes halfway through. And yeah, cool. So there's some symmetry, which I think is a rotational symmetry. By adding together these, you get 1/2. So it all balances out sort of nicely. That side goes up the same amount that the left side goes down. Chris tells me that I should look at top chat because something fun's happened. Erdish's website has got 70 thumbs ups. That's the most. Wow. We like websites here. We're nerds and we like websites. Thanks for pointing that out, Chris. And thanks to 70 people. That's more than the number of people watching the stream. There's only 50 people here. I don't like saying the number because it puts it in the it means people watching it years later know how many people were here live. It's a small crowd. We got 50 people. That's a big crowd, really. If you put them all in the office, they wouldn't really fit in the office. Yeah, 70 upside, 70 thumbs ups. Amazing stuff. Well done, chat. Very, very good. Okay, cool. We're not going to do the differentiation part at the end. You can talk about odd and even functions. It was a thing for this question. Do I regret it? I regret the typo. And if it hadn't been about odd and even functions, then we wouldn't have had the typo. Cool. Right. Good. I guess if you have like separate, like plus and minus, separate. Like, anyway, right. Cool. More voting. Voting will continue until we hit 7 o'clock, I guess. Oh, I need to remove some more options because we've now talked about 5 and I've decided I'm not really going to talk about 4. There's a video if you want to go into the details of how the solution for 4 works. If you want to ask me a question about 4, give me a question about 4, but hey. Gonzalo wants to know what goes wrong in an interview where somebody gets 95 on the mat and then doesn't get made an offer. Well, they actually say they say what goes so badly wrong with that someone 95% of the mat doesn't get an offer. But the answer is probably interview. But yeah, I just did a little bit of question 4. It wasn't supposed to make sense really so much as I wanted to show that you can jump in the middle and just think about triangles. The question itself is quite hostile. It's all about odd and even functions, and not hostile. It's just quite alien maybe or unusual that it's got these odd and even functions there. But in the middle, there's a bit about triangles. How big are they? And people seem, I think that bit of the question was more, I want to say more successful. I don't know that, I should look at the stats. I think the middle of the question with the triangles, people are on more solid ground for that bit, talking about how big triangles are. If your strategy is to do bits of questions, then you can get some marks from the middle of questions. You do not need that. I don't understand odd and even functions. Yeah, we confused a lot of people about odd and even functions in 2020. The idea is supposed to be whether it has, well, the first part is like, what symmetry does it have? This is a transformation of graphs question. So this is the transformation where you reflect in the y-axis. Transformations of graphs are on the MAT syllabus. They are on the MAT flashcards. So you should know that that's a reflection in the y-axis. And if it's equal to f of x, then after reflecting, you get back the same function. That means it has symmetry. That means that after doing that reflection, you get the same thing. So for example, that's what's going on with this first part of the question. The second part's harder because it's combining together 2 or 3 transformations. We've got 2 minus signs. So 2 things going on. What's the result of doing both of these? And in this case, it's a reflection in the axis and the y-axis, which, if you think about it, makes a rotation. We did that with my business card on one of these live streams. Did 2 reflections, makes a rotation. Okay. Question 2 is winning the vote. Question 7 is looking good as well. I want to do a short question. Let's do a quick short question. Let's go see what's going on with 1E. 1E's got some votes. Oh, 1I. Ah, sorry about 1I. That's not one of mine, but it was. Caught out a lot of people. It may have been less correlated than I'd have liked with MAT score. When? MAT results day. Okay, enough voting. The voting is come out for the third place, question 1E, and then we'll look at question 2. And if we've got time, we will skim through some other questions. I've received an interesting email, but I can't read it now because I'm on a live stream. Is that muted? That should be muted. Professional live stream. Right, okay, tangent to parabola. So this is this one of mine? This might be one of mine. This is mashing together ideas about tangents and areas. The area is a little bit awkward to work with. I'm going to try and draw a really good picture. Here's the parabola. Yeah. Here's the parabola. We want the tangent. Worth having the picture before we've done the algebra. I should be better at drawing tangents to parabolas because quite often there's a tangent to a parabola in one of these MAT questions, right? It's at the point a comma a squared. Oh boy, am I glad that that thing is the square of that thing, because that is how that equation works. Good. So that's the point on the curve. A comma a squared. We would like the area of the region bounded by the parabola, the tangent line, and the x-axis, which I think is this area down here. So to find it, I had to look at the parabola and the tangent line, and that's like a big bit over here and a big bit over there, and the x-axis is over here, so I guess it's this bit, which is curve on the top and some straight lines on the bottom. I don't know a formula for the area of a shape that is two straight lines on one parabolic side, but I do know how to find the area under a parabola. The area under a parabola would be the integral, like this. That's not quite what I want. I want to subtract the triangle here. I want to subtract it off. There are other approaches you can use. You can do some sort of complicated split where you break up the shape in the middle here and talk about the integral under the parabola, followed by this difference of curves approach for the second bit. But yeah, okay, something like this. So once again, we need to integrate something. To integrate that x squared, I get x cubed over x between 0 up to a minus that triangle. Where is this triangle? I know the height of the triangle is a squared. I don't know the base. I don't know the base. Divided by 2. Oh, okay, right. I've got to find the base. I know everything, right? I know the given parabola. Y equals x squared. In terms of a, if you give me a, that tangent set, and then this point where it crosses is probably going to be okay as well. So what is that tangent line? I'm going to try and just write it down. I'm going to see if this works. So the derivative when x equals a would be 2x, so 2 times a, I'm not done, 2 times a for the gradient, and I want to make sure that it goes through the point a comma a squared, so I'll do this trick where you write down the bracket and add that on, so that when x is equal to a, the bracket is 0 and you get a squared, and the gradient there is the coefficient of x, so that works out, and I've written down my tangent. Y is equal to 0 then at x is equal to, you've got to rearrange this, minus a squared divided by a divided by 2, add on the a over 2. Check it, plug in the a over 2, you get a over 2 inside the brackets, the over 2 cancels out this 2, you get a squared, so you get 2a squared, oh no, minus from the inside the bracket. Plug it in, check it, a over 2, take away a is minus a over 2, multiply by the 2a, you get an a squared, you lose the 2 on the denominator, put the 2 in the numerator, you've got this minus sign on the a squared, cancels the a squared, you get 0. This is a over 2, the height there, the width, the base of the triangle must be also a over 2. A over 2 on the left, a over 2 on the right. Okay, so that's going to be a over 2. Okay, sort of thing that's much faster to write down than it is to actually do. So what have I got? I've got a cubed over 3 minus a cubed, o cubed over 4. Which is over something over 12. A cubed over 12, is it C? Stake my reputation on it being C. Question in the chat. Silly errors matters a lot in the multiple choice questions because they're just marked for getting the right answer. Silly errors in the long question, you might still get some marks because we can give you method marks. Because then you get grad students to look very carefully at what you wrote, and if you says 3 clever things and 1 silly thing, they're probably going to give you 3 out of 4. It is C, thanks Jack. Yeah, distances, finding distances. Question 4, can you assert that all even functions can be written as a power series? No, because they can't. All odd functions can be written as a power series with odd functions of x? No, because also false, sorry Drax. Some functions don't have power series, which is a shame, because you've obviously heard about power series, but nobody's told you that not everything has a power series. Sorry about that. I guess that's advanced power series knowledge, that they don't always exist for a function. Not everything is perfectly smooth. Is at used? No, at is used on this live stream only by me and nobody else. I use at as a shorthand for where is this thing happening, because we have a shorthand for where things are at. Nobody else does this, it's just me. Yeah, it's true for analytic functions. The ones in the question aren't analytic. So it's strange because power series are a very complicated thing that feels like you're doing a very general thing, but actually because you require a power series to exist, you're actually restricting it to just ones where power series exist. This is a bit of a trap of using higher powered mathematics that you need to know when it works. One person in chat uses that as well. Anonymous person. You and me. There we go. We can make this happen. Right, 1E didn't win the vote, did it? Question 2 won the vote. I can't remember what came second. Was it 7? Okay, we'll do 2, and then we'll have a think about what we're doing next. Oh, I know this question. This question is secretly about binary, but not very good secret because it says binary right there in the question, and then you don't actually have to use any binary after that. The last parts are the hard parts, so I guess people want to talk about the last parts. I'm not sure I've got time to do all of it, is the thing. So this, I know this annoys some people, but I'm going to go quickly through the first parts and then focus on ideas for the last part. It's just what I do when I'm running out of time. Sorry, if you really want to go in deep into the way the first parts of the question work, then I'm afraid you need to try it at home, and if you like, you can watch the recorded video, which is 2 hours long and goes through the first few parts in quite a lot of detail. I'm not going to convert 100 to binary on the live stream. 100 is in S, so S is made of this set, where you start with the fact that the number 1 is in the set, and then you either apply F or G. You can do either, you can do them again, and generate new numbers that are in the set. I think what you want to do is something like 100 is G of 25, 25 is F of 12, 12 is G of 3, and 3 is F of 1. 2, 3, 4 brackets. Okay, so combining it together like that. If you work backwards, then you've solved the whole question. Well, this whole part of the question, because as you work backwards, G always gives you even things, and F always gives you odd things. So when somebody asks you about 100, that can't have come, last thing can't have been an F, it must have been a G, because we've got an even number, we've got 100, so 100 must have come from a G. Similarly down here, 200 would come, if it worked, 200 would come, just erased something and then wrote it even worse. We're going to have one more go. From G of 50, but 50 is even, but not a multiple of 4. There's no way to make things that are even but not multiples of 4. Either they came from F and are odd, or they came from G and they're multiples of 4. So if it's even but not multiple of 4, you can't make it. Good, okay. Chat is very excited. Oh, they did it. Chat, you did it. You got 100 likes on the same thing. And it wasn't even somebody asking for likes. This used to annoy me. A couple of years ago, it was cool and hip for people to ask for likes and then get like 20 likes. This makes me much more happy because the person who posted it is completely bemused by their 103 likes. I genuinely don't know what's going on. Right, okay. So this thing about this unique combination of F's and G's is what I've said about odd or even for whether the last thing you did was odds or evens, and then if something's come from a unique place, you can work backwards. Okay, let's talk about these number of elements part. So again, look, part 5. So we've been playing around so far, and then part 5 comes out and says let UK. So this is something that gets my attention and says there's going to be another definition coming. For the next part, we're going to need to understand the definition and interact with this new definition. So it's the number of elements n of s that lie in the range between. And then they've given this quite a strange thing. They haven't said the number of elements in s, because that's infinite. And they haven't said the number of elements that lie between 1 and 1,000, because it turns out that this is all about powers of 2. They've asked for the number of elements of n of s that lie in that range between powers of 2. Binary is involved in this question. There's a lot of doubling and multiplying by 4, so maybe that makes sense. Just having a quick watch. Kai says, give me likes. I predict that. Oh no, I shouldn't predict, but Kai's got 2 likes. The website's got 103 and it is in development. Brilliant stuff. We love websites. We're asked to show that some relationship between the U's is true. Really this means interpreting what these things are. So this is elements of S. This is like the number of elements of S between 2 to the k plus 2 and 2 to the k plus 3. I'm saying between, I mean including the left limit, not including the right limit. I could write this out more precisely, right? But in my head, this is what I'm thinking. These elements are quite big compared to these elements. I don't mean the numbers big. It's going to turn out to be the numbers big. But over here, this is the number of elements of S between 2 to the k plus 1 and 2 to the k plus 2. I hope it's clear where I'm getting these powers of 2 from. I'm looking at the definition of UK. I want to understand UK plus 1, so I'm looking up to UK and I'm replacing the k's with k plus 1s, because that's how you would change a UK into a UK plus 1. You would change the k's with k plus 1s. So there was between 2 to the k plus 1 and 2 to the k plus 2. These elements are about half as big, which is interesting to me because I already know a relationship between the elements of S and other elements of S, that if something's an element of S, then when you apply F to it, you get another element, and that kind of doubles them. It adds 1, but it also kind of doubles them in size. So this feels like it's about the same. Like maybe there's some sort of relationship between the elements on the right and the elements on the left. We're going to try and show that there's the same number of each, so it'd be nice if there was some sort of relationship between them. This U is the number of elements, but these elements are between 2 to the k and 2 to the k plus 1. These elements are quite a lot smaller than the ones on the left. And I know the elements themselves are not on the left or the right, it's the numbers involved. But the elements involved in that last term are quite a bit smaller. They're about 4 times smaller than the things on the left. That reminds me of G, which multiplies things by 4. So the strategy for this part is to say, aha, each element on the left, these quite large elements, has either come from F or G. Same idea actually, either come from F or G. So therefore it's either F applied to something that's a bit smaller, or G applied to something that's quite a lot smaller. And if you can make that precise and write out, oh okay, this is how all of the elements of U k plus 2 work, if you can make that precise, then you can explain one. All of these elements of U k plus 2, I know where all of them come from, either this term or either this set or that set. I should add them all together, add together the sizes of those two things, because I want to take all of those elements and either apply F to them or G to them to make them big enough to appear in this set on the left hand side. Yeah, it's a recurrence relation. That's the name for this sort of relationship, where you've got a sequence and it's got some equation that holds, some identity that holds between different terms of the sequence. And it's a bit like the Fibonacci numbers, right? It is Fibonacci, I think, or are the starting numbers different? So start 0 and 1s, maybe the starting numbers are a little bit different. Do we need those? Let's have a little think. What's U0? Those are the ones between 2 to the 0, also known as 1, and 2 to the 1, also known as 2. That is just the number 1, so the number is equal to 1. And U1 would be the elements between 2 and 4, which is, I think, 3 is in there, and so is 4. Yeah, 3 is in there because it's F of 1, and 4 is in there because it's G of 1, which is actually how this works, right? We take the things from the previous thing, we either apply F to them or G to them, and we get all these new things, so we get 2 things. Oh, I suppose U minus 1 is 0 or something. Okay, so the first two terms are 1 and 2. I think U1 is 2. Have I got that right? Oh no, not including 4. Not including 4. Whoops, not including 4. G1's too big. I'm wrong. The number is 1. Why has that happened? Oh, because it would be G of a very small thing, so small that it's smaller than 1. I should not be taking G and F of the same set, I should be taking G of the even more previous things which didn't even exist. Early terms of the sequence are sometimes the hardest ones to think about, because at the edge of the numbers, at the edge of the number line, you've got to think a little bit harder. Yeah, 4 is not. Thanks, Eric. Thank you, Anonymous. I think U0 is exactly 1, because U0 includes the number 1, which is in S. We have 1 as a starting number. Yeah, so it's in S for a kind of its own special reason. That's what you get when you don't apply any Fs or any Gs. So you get 1 here, 1 here. So yeah, if you say 0, 1, 0,1. Yeah, cool. Can't see screen due to chat. Thank you. There we go. It was all a bit messy and wrong anyway. Good. Okay, that's part 5. Actually, this was not even part 5. This was just some other calculations that I did badly. Part 6 wants us to think about S turns out to stand for sum. It wants us to think about all of these things added together. Because it's added together all the intervals, the U, although these powers were very weird, they do fit together. It might have been nicer to be like 10 to 100, 100 to 1,000, thousands to 10,000, but powers of 10, not actually that nice for this question. Powers of 2, that's where it's at. And they do, these sets fit together. So SK would be U0 plus U1 plus U2 plus ... plus UK. And people who don't like it when I go fast will not like me just claiming that. But if you think about how the sets line up, then maybe you can see that SK is U0 plus U1 plus U2 plus, and so on up to UK. And then we can get in, because this is a great fact. We've got a new technology here, so I respect the things we've done before, but I'm sort of thinking that I need to do something new. I've got a new fact now. And actually having a new fact is quite relaxing because it's kind of the start of a new question. I want to interpret all 3 things right here. All these S's, I could just turn them into U's and then hope for the best. And I think if you do that, everything turns out to be all right. That essentially the thing here with the U's means that almost everything cancels out. The 1 comes from the fact that you have to really concentrate at the end of the number line, and that things near the end of the number line don't quite cancel out properly. So that doesn't all quite work. You need to think about the U0s and the U1s and get that. That's how we get this extra 1 in there as well. Okay. Can we write on line paper in the MAT exam rather than exam booklet? No thanks, please write in the exam booklet. We would like to scan your exam booklet so that we can get your solutions. Somebody else has asked whether Oxford is anti-Christian. I don't think so. There's a big Christian society. There's a prayer group for math staff and students. Seems like quite a lot of Christians around. Good. What do I think is more helpful for computer science at Oxford? Is it further maths brackets, statistics or mechanics? I would guess, if you're lucky enough to have the choice, I would guess that statistics is slightly closer to how machine learning works. If you're interested in that, then statistics might be a way in. If you do computer science at university and you want to do machine learning, they will teach it to you. So in that sense, it doesn't matter. But in terms of me guessing what you might like, I think you might like some statistics in your life. Mechanics, less related, I suppose. But that's my idea of a fun afternoon. So biased. Part 6, please, in full. 7 minutes. Yeah, sure. Let's go. Ooh, this is going to look like a mess. I haven't given myself very much space, but I'm going to go for it. So on the left-hand side, I'm going to show you these 2 things are equal. On the left-hand side, I've got U0 plus U1 plus ... plus UK plus UK plus 1 plus UK plus 2. I'm going into slow motion on that last bit just in case. On the right-hand side, I've got U0 plus U1 plus ... plus UK plus UK plus 1. I've just got a feeling that the K's and the K plus 1s are going to matter. That's that first SK plus 1. And then I've got U0 plus U1 plus ... plus UK. And I've got a plus 1. Okay. SK, UK. We can use the previous part. So the previous part says that for K bigger than or equal to 0, so the previous part, 5 says, for K bigger than or equal to 0, it's actually a really good fact. It says that U2 is equal to U1 plus U0. It says that U3 is equal to U2 plus U1. And it says, and so on. We could use loads of versions of this fact. I am going to try and use this fact quite a lot. For example, I would like to use the fact on these 2 terms. They look pretty suspicious to me. I would like to add those together to get UK plus 2. And that is literally the fact that we had up here for the same value of K, if that makes sense. I'd like to say the ones slightly below. They give me UK plus 1. I wish I'd written out another term over here now. They give me UK plus 1, adding together the previous terms, all the way down until I get down to adding together. So I'm trying to zip these two things together using the adding rules that we had until I get down to u1 on the left plus u0 on the right. Doubting myself a little bit, but maybe I should not. Yeah, I'm good. U1 plus u0 is equal to u2. So that's all good. These terms, by the way, all match up with the left-hand side. Look, I'm going to put the u2 in. ... So we've got that one, we've got that one, we've got that one, we've got all these ... terms. The only things we've got left over are, we've paired almost everything up. We've got a u0 on both sides. That works, that pairs up. The only things we've got left are a u1 over here, and we've got a 1 over there. u1 equals 1, so we're equal. I mean, it just is, because the number 3 counts. This would have been my clue that when I wrote down that this was 2, is my clue. Oh no, maybe it's 1, so that this part of the question works. Sorry, I wrote that in the horrible light blue colour. u1 is equal to 1. Cool. Yep, u1 equals 1, that's why that one's there. The u0s work out, everything's good. It's the previous fact, summed up loads of times. Okay. I'm not sure if my pink lines are very convincing. They're supposed to be taking like terms from the first bracket, terms from the second bracket, and trying to pen them together. The first bracket's got more terms in, so they don't all pair. We get this leftover u0, but things work out in the end. Good, and being very careful, because when they pair, they make a u2. They don't make a u1 and they don't make a u0. There's nothing to pair to make those. We get these terms at the bottom here. Okay, using the previous fact, k times. Yeah, cheers. I hope that was the same in non-person. You wanted to see that. And then actually only took 3 minutes. That's pretty good. Good times. Favourite elliptic curve, and what makes it so nice? There is a multiplication property for elliptic curves. My favourite elliptic curve is all of them. Elliptic curves look like this. Right. We've got 3 minutes. Let's talk elliptic curves. Let's see if I can say anything convincing about elliptic curves. Spoilers, I definitely can't. You might be interested in stuff like this, in general, where you've got a cubic is equal to y squared. There are several things that can happen. You can get ones that look like the one we just had. You can get ones that look like this, and you can even get ones that look like a kind of fish, big alpha shape, which is quite exciting. So they have some nice topology going on. Are they connected or not? And they have a multiplication property, which, oh my goodness, I cannot explain now, can I? If you take 2 points on an elliptic curve, and this is going to be very unconvincing. If you draw a straight line between those 2 points and find the third point where they cross the curve, you could do some algebra to work out what that is. I do not recommend you do this algebra at home. Then if you also reflect that point in the x-axis to get down to here, so P kind of operation is a bit like multiplication equals R. You start from P and Q, and using this weird definition, draw a straight line and then reflects down using the reflection symmetry down to R. That gives you something that works a lot like multiplication, which, oh my goodness, doesn't mean anything to you, right? It's nice. It's a nice operation. You can imagine that being absolutely horrible because of the straight line intersection nonsense, but the operation is actually quite nice. It has some nice properties, and whenever we get a nice structure that has nice properties, we can do something called group theory, and we can come in and do some big general mathematics to explain how it works. Pretty good. How do you know the third point where it crosses again exists at all? Great question. Cubic equations. Cubics. What are they like? So the line is y equals mx plus c. If you sub it in, you get mx plus, not c, mx plus k. If you plug it in on the left-hand side, you get an x squared term. On the right-hand side, you get a cubic. So rearrange it, you get a cubic. Cubics either have 1 real root or 3 real roots, and we already know that this has got 2 real roots, so it must have a third. Cubic equations. Raphael's off. Bye, Raphael. Everyone likes Prisma, right? Good. I'm glad everyone likes Prisma. Is it a bit like a scalar product? It's a bit like a group. Oh, I can't do this. A little bit, maybe. Scalar products, no, maybe not, because scalar products, you Scalar properties, you take two vectors and they give you a scalar back. It's like a symmetry thing. Let's not do group theory right now because it's 7 o'clock, which is the end. Prisma's off. Bye, Prisma. Oh, it's Prisma done an announcement in chat. Oh, dead on 7. Bye, Prisma. You're gone. Good times. Can I have a repeated route? Oh, yeah, there's some special cases. Fine, okay, there are some special cases where it's like tangent. I can't remember what that means. Oh, it's fine. In that case, you take the repeated route as the other. You count with multiplicity, so you take the other route and then reflect. Gosh, thanks for making me do elliptic curve stuff on the spot. We're going to wrap up now because it is 7 o'clock. Thanks for making me do this on the spot. If you want to look up elliptic curve cryptography, you have a recommendation, not from me, you have a recommendation from someone in chat ages ago who suggested that you would like to see elliptic curve stuff. Over there, when we do Galois theory and the quintic, this will all come back when I eventually learn Galois theory for an amazing episode of a live stream thing. I think my day's been 5 stars. Thanks for this. Can I draw all of the Greek letters? I did think about throwing another one in there. Most of the Greek letters I learnt because of the maths degree. I learnt how to do Xi and do it properly. Well, no, I'd say properly. I learnt how to do Xi in my style. 107 likes. Oh my goodness, that is the most likes anything's ever got. That website better be great because people watching this video, in the future, people are going to watch this video and they're going to see, like, there's a link in chat. I could type it in very carefully into my browser. I can see one. 107 likes. It must be amazing if we can go back and find that website. What was on there? So Paul Erdouche in chat. You got to make sure that website's good. /secondpage.html. Imagine what the first page was like. Right, cool, brilliant stuff. Thank you everyone for just being positive and nice and fun. Other questions are available. We didn't cover 6 or 7 in the end. I'm sorry, computer scientists. If you want to see my solutions to those, you can see the video solution, which is linked on the Matt Live page, link at the bottom. I will see you again next week for Matt 2021, paper that I really like because it's the first time that I really got let loose and wrote a lot of Matt questions. So 2021 is going to be a lot of fun to talk about next week, I think. So yeah, peace out. I'll see you next time. Let's see if I can stop the stream this time. Goodbye.